The first step of solving nth order homogeneous differential equation is in writing it in a form of differential operators. The differential operator here is expressed as d, which is actually equal to your d over dx. Now take note that the general form for nth order homogeneous differential equation is expressed in this manner: a sub 1 x, the nth order derivative of y with respect to x, plus a sub n minus 1 x, the nth minus 1 order derivative of y with respect to x. Okay, then you see plus dot dot dot, plus you will have here a sub 1 x, the first order derivative of y with respect to x. You have here plus a sub 0 x, and then y equal to 0. This must be equal to 0 so that our equation is a homogeneous equation. What we need to do here is we're going to let all d over dx in terms of the differential equation, operator rather. That would mean we will have here a sub 1 x, then we take here this portion, okay, that portion there. So you will have the form, okay, d, but take note it's the nth order, so you have d to the power of n, and you have here your y, okay? Then plus the next one, a n minus 1 of x. Similarly, this one here, okay, and take note the exponent, the order is n minus 1 y, plus dot dot dot, plus similarly here dx, d over dx. So you will have the form, okay, a sub 1 x d, and then you have here y, sorry, dy. And since this doesn't have d over dx, so we will still stick it as it is, a sub 0 x y equal to 0. The point here is when we write it in differential operator, we can open the idea of auxiliary equation that will allow us to solve the homogeneous differential equation in nth order. Okay, but before this, we can actually factor out y, okay, because y is present in all terms here. So when we factor out y, it would be even better writing this a sub 1 x d to the power of n. Then you have here plus a sub n minus 1 x d to the power of n minus 1, plus dot dot dot, plus a sub 1 x d, plus you have a sub 0 x, okay, times y equal to 0. You can see that inside the grouping symbol now, we only have the coefficients in a differential operator. Take note that the coefficients here with a variable of x as well, okay? So with variable x, or a function of x, a function of x, function of x, a function of x, and the differential operator are arranged into descending order. So we can actually come up with an auxiliary equation representing that, and then writing auxiliary equation will be provided in the next video as well. But the point here is the first step of solving homogeneous differential equation in the nth order is writing your homogeneous equation into an equation with differential operator d. We will have videos, of course, explaining or illustrating this when we are given with a certain nth order homogeneous differential equation, writing it in differential operators d. Okay, and after that, we also be talking about auxiliary equation that will allow us to solve the nth order homogeneous higher order differential equation. Thank you very much for watching.